Okay, everyone, let's look at the situation when an attraction force is causing a negative acceleration. Let's say there's a magnet here, is causing a negative 5 meter per second square for an object which is made of iron and is moving towards this direction, is getting away from this. The initial velocity is 20 meter per second, causing it to get away from the magnet, but the magnet is slowing down the movement. So if the movement starts from here, of course, after 1 second, by the end of the 1 second, the v would be definitely 15 meter per second, right? And then by the end of the other second, it would be 10, then it would be 5, and then it would be 0. So it comes to a complete stop, yeah, and then it turns back and moves towards the magnet with a negative 5 velocity, negative 5 meter per second. Then the velocity which is going this way, negative 10. As you can see, a symmetry in here exists, negative 15, negative 20, and it goes even faster. Of course, in 1 second is having more displacement and it's going, let's say 25, yeah, even bigger velocity of negative 25 actually towards this. This would be another velocity. These are all velocities. So of course now let's see if the formulas that we have worked on are correct. Let's find the velocity after 2 seconds. So this is the starting, the initial, the origin, 1 second, 2 seconds. What is the velocity after 2 seconds? V final equals V initial plus AT. This is the formula we are testing. V final would be, of course, I substitute 20, negative 5 times 2. I will have 20 minus 10. I will have V final equals 10 meter per second, which is actually correct. 1, 2 seconds. This is my velocity. And then see what is the velocity after 7 seconds. Let's find the velocity after 7 seconds. V final equals V initial plus 80. V final equals 20 plus negative 5 times 7. V final equals 20 plus, 20 minus 35. So the V final would be negative 15 meter per second. Let's see. 1, 2, 3, 4, 5, 6, 7. Yes, it's negative 15. So my formulas are correct, of course, and we are just analyzing them. Let's find the displacement. Displacement after 2 seconds. So this is the formula for displacement. VIT plus half AT squared. So it is 20 times 2 plus half of negative 5, and 2 to the power of 2 would be 4, right? So the displacement would be 40 minus 10. Displacement would be actually 30 meters. So from here to here in 2 seconds, the displacement would be 30 meters. From the origin after 2 seconds. And then let's find the displacement after t equals 6 seconds. Let's see what will happen. Of course, the d would be VIT plus half AT squared. The d would be 20 times 6 plus half of minus 5 times 36. So the D would be 120 minus 90 actually, yeah. And so the D would be again 30 meters. Look at here. Let's see. 1, 2, 3, 4, 5, 6. Yes. So after 6 seconds, again the displacement would be like this. This is why you can see that displacement, as you know, is different than distance. So you can see displacement is from where you start and where you end up being after 2 seconds is equal to after 6 seconds. This is very interesting.